My name is Ryan Peak. I work at the Center for Watershed Sciences. I'm in the ecology program, PhD program, and I'm going to talk about Markdown. What I was starting to say is Markdown is really great. It's natively incorporated with RStudio, and if you were just to open a new Markdown file, this pops up. And you can title it at whatever you want. You'll see a bunch of different options. The nice thing is, even if you select one of these, you can always switch it. You can format it to a different one very easily. So it doesn't really matter what you pick. If you don't know, you can do presentations. I'll show an example of that earlier. And I think your slide presentation was using Shiny as well, or Markdown as well. So, and then you can make an actual standalone Shiny app. And I'll show an example of that. And these are basically either a document, which is what I'll show you is a document, or a presentation, and there's only a slight difference between the two. So anyway, there's lots of really nice options here. And then when you do open it up, it adds these headers into the top of your document. And you'll see these headers have the important bit. The top 3 lines is almost always title, author, and date. You can change those as you like, but the important bit is the output here, HTML document, or you could put slide, presentation. There's a bunch of different options. And then if you want to include Shiny, or the ability to make it sort of a dynamic document, which I'll talk about, you just add a line Shiny. Within this document, if you up here under the question mark, there's this using our Markdown option. There's also a Markdown quick reference, which if you click on that, just gives you sort of the basics of how to write in Markdown. And it's a very simple, basically, essentially it's HTML coding with a few little things thrown in that make it much more simple as far as making something italic or bold, adding headers. But the nice thing is if you do know HTML code, you can add that and it will read it natively as well. So if you have any experience with that, that's another a big perk, because you can sort of customize your document as you like. But what I was going to show you is if you click on this and then click on this using our Markdown, it will bring you to the page I was just on a second ago. And what's cool is this really gives you everything you need to know and more about how to use Markdown, the different options available. So if you're authoring any of these sorts of documents, interactive, embedding Shiny apps, even bibliographies and citations. I will say this is something that's a little trickier, and I've tried to use it to some degree with a little bit of success, but I would say that's probably the part that is still being worked on the most, because I don't think it's as natively integrated with things like BibTeX. I mean, it uses a lot of that, or EndNote, or any of these nice programs that you can use with Word. But it has a lot of different options on these different formats. If you want to make a PDF or a Word document, slides, and they have all kinds of great examples and code on how to do that. Like if you wanted to click on this, it gives you all these really great details on how to set things up. And it largely boils down to, at the header of your document, you just change a few lines that basically tell it what kind of document you want it to be. Okay? So let's go back to our document. So I'll sort of flip between what this looks like once you sort of click so this is the original document here. And then when I hit run document, this basically goes through and formats it into this. And there's many, like I said, there's many different formats. You can make it look in different text types and shapes and colors even that you want. But essentially, it's really flexible. The nice thing is that there's a lot of great blogs on how you can even write a manuscript. There are some folks who are starting to really advocate using this plus version control, and you could actually do manuscripts just in Markdown, which is pretty awesome. And I put these links up here. You can check them out. There's a whole series of blogs on how you can do that. The nice thing is that, particularly if it's a code heavy or something that that works well with that, I think it's a really great option, and it's very clean. The downside I would say is that if you're not comfortable with version control, using GitHub or something similar, Bitbucket, whatever it might be, it could be somewhat of a drawback for folks that are really used to using sort of Word and using the comments and reviewing options of that, of track changes, which is great. And so I think there's pluses and minuses to both sides, but whatever works for you is ultimately what's going to be best. There's another nice piece here on balancing the need to learn every new tool and package that comes out with actually just doing what you need to do, and how much time you sort of invest in doing one or the other. I will say Markdown has a very low learning curve, so it's really worth doing, even just in your analysis. I find it's nice because you can just bring up a document and just kind of start typing what you're doing, then add your code, and so it becomes all one big thing. Or you can have maybe three different documents that's like, step one, I did this, and here's what I did. And I'll show an example of that. So it's really nice, and then you can send that on to somebody else, and they can look at it and say, well, I would do this differently. So anyway, there's basically, basic headers you can change with just that hashtag. So this is in the text, you'll see, and I'll share this so you'll have the raw text. But if you want to make something bold, you're just using these asterisks. If you want to link something, you essentially just put the link in and then put a set of brackets around it. You can include pictures, which I'll show an example of. Breaks are essentially either a bunch of dashes like this or a bunch of asterisks. And headers are simply just a different number of, whether you do 1 or 2 or 3, and you can even go to 4, will give you the different headers that you want. And so images, you can just basically link straight from a website to the actual picture, or you can use something on your computer locally. And so some of my favorite pictures of a Cuban tree frog swallowing a Christmas light, which you can debate ecological trap or whatever you want to talk about. But so this is straight from the website. This picture below here is from my computer. And so one important thing to mention with figures or pictures, if you do link directly from your drive, you want to make sure that this picture is in the same location as your R Markdown file. Otherwise, it can't find it, because what happens is it as soon as you sort of click format or turn into HTML, it essentially makes that wherever that file is, that's the root drive, or that's the source file location. So it has to be in that same place. You can have subfolders within that. You can make like an images folder, and then that's where you can put all your figures or your images. But that is one thing to keep in mind, is whatever sort of additional stuff you want to add, it has to be in the same place as your file, as your original Markdown file. The other nice thing is you can add equations, special text, and whenever you click knit, it will generate all of that content. And so this is, I don't know why this is so tiny, but that just says it's basically, a fake equation. Or you can do inline, you can add in the actual line of the text, you can add the equations, or you can just add actual code and it can output as the actual 2 + 2 = 4, or whatever it might be. Or you can set it aside, set it apart. Like if you want to show some specific logistic equation that's really important from a modeling output, you can make that sort of on its own in its own code block here. And there's lots of help on, you can also incorporate HTML codes. So if you wanted to add, degree signs or certain marks that are really commonly used, there's really easy ways to do that. And there's some great resources online here showing you what the basic HTML code is for each of those. Let me go back to the script so you can see that, what that all looks like. And again, I just try to throw in a bunch of different examples so you can look at that, and I'll post this script up so you can look at it and play around with it. There's a lot of great examples online too. So if you wanted to set an equation sort of on its own by itself, you use these $signs, double $signs. If it's in line in the text, you just use a single $sign. And then if you want it to interpret something in R, like an actual equation, you'll see 2 + 2 is just the text here. But the output of that is actually, it's sending it to R. R is then running it and spitting that result back out in text. And you just use these little apostrophes, essentially. And then if you want it to stand alone in its own code block, whatever it is, as is, this is you use 3 in a row, which we'll talk about. That's how you insert code chunks further down. And then this is HTML codes here. Okay, so is everybody with me? Any questions thus far? All right, cool. Now, if you want to insert a code chunk, up here in the upper right, you'll see this thing says code chunks. You can insert a chunk anywhere in your document. So if I went up here and hit insert chunk, it'll basically put this in automatically. Now, whatever you want, depending on how you want to format things, and I just talk about that a little bit down here, there are different options. You can add, it'll look nicer in this, so let's look at that. You can add echo equals false, which will prevent the printing of any code that's not, you don't want to show up in your document, or any of these other ones, comment, warning, message, all suppress or reduce the amount of code or an output that's printed. Some of that you may want. So if you just be aware, you can turn those on and off. It's also helpful sometimes to adjust the figure width and height. This is like a moderately high DPI, so it makes the figure look pretty nice. You can actually make that even bigger if you want. But you can change the width and height, and it natively sort of will adjust to your screen size, but this seems to make it look fit nicely. So if you do use eval equals false and echo equals true, it will simply, it won't evaluate the code, it'll just simply print it. It'll just show this is what I wanted to run. This is a plot of, you know, cars and adding a horizontal line. Now, if you change that to eval true, so here's the header, the code chunk that was run is right here. Okay, it shows this plot natively in your when you knit your document or convert it to HTML. And so you can either you can show the code and then show your figure, or you can just show the figure. Either way, and you can see it's really nice and super easy to do, and it's very customizable. You can make your figures as complicated or not as you would like. So are there any questions on that? Yeah.
So if you want to install libraries, I just started using this yesterday.
Right.
I put my library
Mm-hmm.
into the barcode.
Mm-hmm.
Into that amount of Word doc or whatever.
Mm-hmm.
Is that the case when you use the echo to show that you're installing these libraries?
Right. So that's one of the options is if you play around with echo equals true, it'll print everything that's in there. And if you do echo false, it generally will repress a lot of those basic things that it's just running the code, which is nice. So if you don't want that in your output, that's definitely something. The other one I would say that's helpful that I've found is message false sometimes is nice, because a lot of times it'll say like loading library or something like that, and you don't really need those messages in your document. So you can play with those. Warning is up to you. Sometimes if you know the code works, you can get rid of that, and if it's in warning, you can ignore. That's another one. But yeah, those are things that you would you wouldn't want in your document, right? So I'll give an example, because the next code will show why that can be helpful. So let's see here. In here, so these aren't requiring any libraries. But if we wanted to do something with Shiny, now keep in mind, if I didn't include at the very top this runtime equals Shiny or runtime : Shiny, these components wouldn't work. So you need to make sure that's in your header. Shiny, I will say, is pretty straightforward, but it might be, for those of you that haven't used it, it might be a little bit confusing. Just bear with me. in here, again, I'm loading data. So this is just an R chunk, right? So an R code chunk. I've added these basic things up at the top. I'm loading data that is in the same location as my Markdown file. So again, you need to have your data in the same place. I could make a special data folder and then call that, you know, like that, so it would know, but it's all, again, in the same place. Then I'm requiring my packages here that are important for the code chunk. And then Shiny. There's two parts of Shiny that you need to know for these dynamic documents. There's an input and then essentially a render of some sort. So input panel is essentially, this is in Shiny, this is where you say what different buttons and sort of interactive pieces do you want people to play with. So in this case, I've taken basically the precip data from R, just one of the available data sets. It's like precip in cities across the US. And I've then added some fake data on coefficient of variation and some other things. And then I also geocoded, and this code is all here, so if you want to do this yourself, I'll provide it. I added the longitude and latitude for each city using a geocode package, which is part of, I think it's part of ggplot, but I'll double check to make sure that that package is there. So anyway, you have this data set, and so what I'd like people to be able to do is click on a different city. It'll highlight a bar plot basically of what city and what that precip is. And then if they also want, they can click on another button. It will say, show me a map and show me where these points are on the map, and maybe highlight the city that I'm interested in. So basically I need to make an input for the city because they need to select a city. And so under the select input, and I will say the Shiny has an associated page similar to the Markdown page that gives you all the details on Shiny sort of commands and functions. But within select input, it gives you these options: an input ID, which is what you're going to end up needing down below for your plot. And then a label for that ID or that box, what choices you want to make available, and then what your sort of default selection will be. So cities, my label is cities. I'm selecting Spokane, and then these are some other options just within the drop-down box that I'm making available. And then this basically is the part from my actual data. So my actual data frame with my data has a column with cities. And so it's basically looking in that and saying, okay, these are all the cities. I'm making a drop-down box, and someone can pick from that box, okay? The next part is a little bit, let me make this a little bit easier to see. The next part is essentially a checkbox input, which is the map. So it's a map city, and it's just a true false. So if the box is checked, it's true. If it's not checked, it's false. And then there's a sort of conditional panel that will pop up if you click on that box. And this code is really important. It's input.mapCity, which is this value. And if that is true, then it will show this slider input. And you can put any other input you want. But essentially, I'm going to change the point size of the city in question. And so you can make that slider min, max, and the value and the number of steps within that. And then some help text on how that, what we're looking at and how that works. Okay, so now that's the input panel part. Now the render plot part. So now this is ggplot. So those of you that are familiar with this should look pretty similar and pretty basic. There's a lot of options in here that are just plotting options. So this first plot is simply, this plot's just natively without any dynamic components, except whatever city is selected above from the input, it's going to just basically say input cities is, I'm basically saying if the input city matches the data set city, then it's going to make that a different color. That's really all this does. And all you need to do for that is this input $, whatever your value is. Okay, so it's just basically you have your input, and then in your actual render, it's always input $, something that you've called from above. Now, below that, this if statement here is if map city equals true, which is the little checkbox you'll see in a second, then it's basically going to make a map of the data. And then it's going to also include this input city size. So depending on what the slider value is, it'll make the size of that point different. Okay, so I know that's a lot to throw at everybody, but let's look at the actual document and it will make a little more sense. So this is what that all turns out to look like. So there's a drop-down box. Here's all these cities. If I click on a different city, it's going to turn that city blue. It's going to highlight that. You can do all kinds of different stuff with this, and really the sky is the limit as far as what you want people to look at. You could change. You could add a regression line. You could do modeling options. You could just do point plots. I mean, the sky's the limit, and there's plenty of great examples out there. So this is just showing the annual precipitation and then some fake coefficient of variation in the red below that. Okay, so if you click this box, remember this is the true false value box. If I click that, automatically it's going to load this map because it then is essentially saying, oh, that box is clicked. That means instead of the other plot, I'm going to show this map. Okay, so now whatever city is clicked, it's going to show that as a red dot. And now if I wanted to change the point size, which this is sort of meaningless, you can just make the dots bigger. But you get the point. You could do that just for your city. You could do that for a set of cities, or you could say, I only want to look at precipitation for a certain range, whatever that might be. And this is color coded by the amount of precipitation. So typically you're seeing less precip in the Colorado Rockies and out into California, with the exception of of some of the coastal cities here. So that's basically all that is. It's pretty straightforward. Does that make sense, everybody? Okay. Now I'm going to show you a quick couple examples, and then I will be done. So presentations. So one of the nice things is if you have, so this is an R Markdown document, and I've made it into a slide presentation. And this was a great option to share with other folks that we were working with on this temperature analysis. And I added a map of where our data was, and they could sort of pick a different, this is temperature data up in Mulkey Meadow, or the Kern Plateau. Essentially, we have a bunch of temperature data looking at Kern golden trout. And so maybe we want to look at where are the different loggers within the stream. They could click on that and see, okay, here's the loggers, okay? And then the really cool thing is, one of the issues we were running into is a lot of these loggers got buried by sediment just from winter flows and snow melt. And so we had to filter those out and chuck them because they were giving us, basically a bad set of data, because they are completely buried by the sediment, and then there's no diurnal fluctuations. And so I made this to basically go through and quickly look, instead of making a ton of plots and then looking at them. This was much easier to do, and to show someone the process that we went through to do that, I made this as well, which was nice. So for a given month in August, which was the one we were really most interested in because it gets the warmest, we were interested in which loggers, how long are they out, what's the diurnal range. And then here you can see, obviously, the diurnal range is very much compressed. So that would be one automatically. I'd be like, flag that logger. We're going to take that data out and chuck it. It was reset here. Somebody probably dug it out and put it back up where it needed to be. And so you could play around with this and look at the different loggers. And it's nice because now you can see what good years you have, what bad years you need to get rid of. All this sort of interesting information that is useful. And then if you want to look specifically at a given year, I added another option. Remember this conditional panel, the same thing, where you can essentially pick a year of interest and then look just at that year. And then you can also play with, if the 7-day maximum temperatures exceed 20 degrees or 21 degrees, you can get a sense of like, okay, what days was the 7-day max really, really high? So it's been pretty warm in there. And that's another sort of important metric for biotic for fish, basically. So this is nice. And then you can make another, you can make box plots of looking at a range of temperatures or months for, across these different loggers and times, or you can box plot all the loggers so we can get a sense, okay, you know, obviously this one looks kind of weird. Why is that so compressed? Go back and look at the other data and, oh, guess what? It's been completely buried, that's why. So we were able to make this and share this with folks, and essentially it was really helpful because it was a way to sort of show this is the process we used with the data, this is how we filtered it, and then from that you can make another R Markdown document that shows just your filtered data, and then provide that for more analysis, actual specific analysis of temperatures. So I will say that's a nice sort of example of one of the things we've been doing with the Shiny apps. Some of you may have seen this before. This is another specifically Shiny app that we provided so that folks could download temperature data for a given river, and we update it at many different times. But they can pick the year, they can pick the river, they can pick the logging interval, and then they can essentially look at the data, look at these plots, and then they can actually download the data. And if they're interested, you can add tabs and a lot of other options where you can say, okay, these are the study sites. You know, I want to look at just the Yuba sites, and then you'd go here and click on the Yuba site, and it would bring that data up. So yeah, that's basically all I've got. Hopefully that makes sense and is helpful. And there's a bunch of links and resources in this document that I'll share with you all. So hopefully it's a good example. Yeah, no problem. Any questions? All right, well, sweet.
So could you talk about what the original document needs